Hello everyone. Today we are going to discuss about the relation for de Broglie wavelength and temperature. How de Broglie wavelength is associated with temperature we are going to discuss in this session. Done. As we know from kinetic theory of matter we have studied in plus one. According to that, average kinetic energy average kinetic energy of a particle at temperature T. Average kinetic energy of particle at temperature T Kelvin is given by kinetic energy K is equal to 3 by 2 kBT. 3 by 2 kBT, Kb stands for Boltzmann constant. Kb stands for Boltzmann constant. Done. If a particle of mass m moving with the velocity v, we know its kinetic energy is given by kinetic energy is equal to half mv square. Done. We know that linear momentum and kinetic energy are related. Divide by m and multiply by m. We get mv whole square upon 2m. mv stands for momentum. Kinetic energy is related to momentum, like kinetic energy is equal to p square by 2m. From here we can write p square is equal to 2mk. K stands for kinetic energy. We can write p is equal to root of 2mk. P stands for linear momentum. Linear momentum formula, you know, p is equal to mv. Done. We are saying that relation for de Broglie wavelength and temperature. We know that de Broglie wavelength associated with a moving particle is given by lambda is equal to h upon mv. H upon, we can replace mv by p, and p can be replaced by root of 2mk. Done. We know the value of k, that is average kinetic energy of the particle at any temperature T, is given by 3 by 2 kBT. Then average kinetic energy, what we will get from here, lambda is equal to h upon root of 3m kBT. Done. De Broglie wavelength associated with the temperature, or relation for de Broglie wavelength and temperature, is lambda is equal to h upon p is equal to h upon root of 3m kBT. Kb stands for Boltzmann constant and T stands for the temperature. Thank you.